So in this video, we're going to start looking at task 14 on page 2 of your Unit 2 packet. Before we get into reflection, we're going to review a few things about lines. So on a coordinate graph, we have our X and Y axis. So remember, this is my X axis. This is my Y axis. And we want to talk about the special cases where we have like Y equals A, or for example, Y equals 2. And what does that line look like? So we want to think about, okay, where is Y2? And Y is 2 where we come on the Y axis and we find that point where Y is 2. And so this point is considered 0, 2. And that's one place where Y is 2. But Y is 2 also here, this point of 1, 2. And Y is 2 also here at -1, 2. And so Y is 2 anywhere on this line. And so I can draw a horizontal line through those points. And that represents Y equals 2. And so Y equals A, where A is any number, always looks like a horizontal line through the point 0, 2. Okay. Or you come to 2 on that y-axis and you draw a horizontal line through it. And y equals 0 is actually the x-axis. And this always messes up students, but it is the x-axis because anywhere on the x-axis, no matter what point I pick, this is 1, 0, this is 4, 0, 3, 0, 4, 0. Any point I pick on the x-axis, the y coordinate is always 0. And so y equals 0 is the same thing as the x-axis. So y equals 0 is this line, which is the x-axis. So then if we think about x equals b, so for example, if I said like x equals 2, and I do it on this axis, so we have again our x and our y axis. So we think, where is x2? Well, this is 0. I would come right to get where x is 2. And x is also 2 here, and here, and here, and here. Okay, so this point would be like 2, 1. And this point would be 2, 2. And this point would be 2, -1. And so x equals a number is always a vertical line that goes through the x-axis at whatever that x value is. Okay, so x equals b is a vertical line through the point. And so if we have b, whatever b is, comma 0. Okay, or again, you can just come to whatever that number is on the x-axis and then draw a vertical line through it. And then x equals 0, therefore, would then be the y-axis, because any point you pick on the y-axis, like this point, is 0, 1, 2, 3, 0, 4. Or if I pick like here, this is 0, -1. And so the y-axis, any point I pick on the y-axis, x is always 0. So x equals 0. It represents the y-axis. And so it's backwards what a lot of students think. So please make sure you remember. It's pretty much, if it's y equals number, it needs to cross the y-axis, and then it's a horizontal line. And if it's x equals number, then it needs to cross the x-axis, and it's a vertical line. So a lot of Unit 2, we're going to talk about transformations. So a transformation is a rigid motion that moves an object from one position, and the object we start with is called the preimage, to another position, the image. Transformations preserve the lengths of the segments, angle measurements, and parallel and perpendicular lines. So we are going to talk about 5 different types of transformations. We're going to talk about reflections, which are flipping over something. We're going to talk about rotations, which are turns. We're going to talk about translations, which are slides, and dilations, which is where we're like either enlarging a figure or shrinking a figure, and then a glide reflection, which is a combination of a reflection and a translation. So we are going to use this graph here for pretty much all of these problems. And so if you are someone who wants to do it on like the computer and not paper, I have a link to it on GeoGebra. So you could always type this link in to your browser and then it will come up with this picture, and then you could do it on your computer instead of on paper. So in this video, I'm going to do problems 1 and 2. And then in another video, I'm going to do problem 5 and 6. And then you're going to do problems 3, 4, and 7 for homework and submit it on Canvas. And then in class, we will do the other problems together. So the first thing we're going to look at is reflecting over the y-axis. So we are going to take this design one, this figure here, and we're going to reflect it over this y-axis. So I drew a dotted line for the y-axis so I knew what I was reflecting over. And it says use design one, reflect that in the y-axis. Your points when reflected need to be the same distance from the mirror line, which is this y equals, or sorry, is this y-axis, or x equals 0. Complete the table below that shows the coordinates of each of the points after the reflection. Okay. So these are all the points of the pre-image. The pre-image is my original figure. I am going to flip this figure over this line to get a new figure over here. And that new figure is going to be called my image. Okay. So when I'm reflecting, what I do is I pick a point on my figure. So we'll start with A, and we count to our line of reflection. So if I count from A to my line of reflection, I go over 1, 2, and then I count that same distance on the other side of the line. So every point needs to be the same distance from that line. So I'm going to count 1, 2, and make a point. And so how we know it's the image is we write that letter again, but we put an apostrophe on it, and we read it as A prime. And that's our new point. So again, this is the pre-image, and this new figure over here, we're going to get is the image. And so how we know it's the image is we put an apostrophe by each point. And so then we're going to write those coordinates. So the coordinates of that point, A prime, if I look, is that -2 is the x value, and 2 is the y value. And so I'm going to do this for every point in this figure and then connect those points to make this figure. So if I take B, I would count B is 1, 2 for my line. So I would count again 1, 2 on the other side of the line. So B, and this is B prime. Again, B prime has to be the same distance from the line as B, just in the opposite direction. And so we're going to do that for every point. So I count C, it's 1, 2, 3, 4, 5. And then I'm going to count 5 in the other direction. 1, 2, 3, 4, 5. And then I'm going to put C prime. Then I'm going to do D. So D is 1, 2, 3, 4, 5 to that line. And then I'm going to count again 5 on the other side of the line. 1, 2, 3, 4, 5. And then this is D. Then I'm going to do E. So E is 1, 2, 3, 4. And so I'm going to count 1, 2, 3, 4. And I really don't like this figure. It's hard to like write all the primes. I'm going to connect these now so that I have it. So I have A to B, then we connect to B to C, just like over here. C to D, D to E. So this is an E. Then we're going to go to F. So F is 1, 2, 3, 4, and then I count 1, 2, 3, 4. So this is F. Okay, and it gets kind of tight in here. F prime. Then we're going to do G. G is 1, 2, 3, and so you count 1, 2, 3. Okay, and you can also base it on the other points because it should be the same. So G has to be one away from, G prime has to be one away from F prime. D prime has to be one away from E prime, just like the other ones. Okay, so you can also do it that way once you have some of the points plotted. If I do, now I'm on H, so H is 1, 2, 3 to the line. So I'm going to count 1, 2, 3 to get H. And then I'm going to connect that. And then I connect A to H. So sorry, it's hard to read some of those, but this is G prime. It's just so tight in here. That's F prime, E prime, H prime. Okay. And I'm going to write my coordinates. So B prime is at -2, 8. G prime, sorry, C prime is, let's see, at -5, 8. G prime is at -5, 5. Okay, so if we just stop there and look at a pattern for this, what we can see is, okay, A prime, the X coordinate is the same number, but opposite signs. The Y coordinate is the same. For B prime, the X coordinate, same numbers, opposite signs. The Y coordinate is the same. The same is true for C and the same is true for D. And so if we're following that pattern, then E prime, we would think, okay, the X coordinate would be negative and the Y coordinate would be positive. And if we look at our graph, E prime, again, is here, is -4 and then 5, and that's true. Okay, and so same thing, F prime, if you look, is at -4, 7. G prime is at -3, 7. And H prime is at -3, 2. And you can check them all in the graph. Okay, so what do we notice about the ordered pairs? And I'm going to do a general rule for the reflection over the y-axis, not just these points. So what we notice is when we reflect over the y-axis, what happens is the X coordinate, sorry, excuse me, changes sign, but the Y coordinate stays the same. We're going to write this as a rule. So how we write it as a rule is we write XY to stand for any initial point, and then I'm going to put arrow, so becomes, and in this case, it becomes the opposite of X, or -XY. And why I'm writing it this way is because, say I take this point here, I'm going to call it I, and that's my pre-image, which is at -3, 6. If I reflect that, I would count this way now to the right instead of left, 1, 2, 3, and then I'd count 1, 2, 3 to get this point, I prime. And this point is -3, 6, and this point is 3, 6. And so the same rule is applying. I'm doing the opposite sign of X. So if it's negative, it becomes positive and the Y coordinate stays exactly the same. Right? And that's what happens when we reflect over the Y axis.